Ouch. Gravity. It seems so simple, but how does it actually work?
The world of science has heard a lot about gravitational waves earlier this year when they were discovered.
But to understand these, first we have to understand gravity as a whole. When we jump, gravity grabs us and pulls us down, right?
Not exactly. This is a common misconception. So when I drop this pencil, nothing grabs it and pulls it towards the ground. So how does it actually work? See, when visualizing gravity, we have to imagine space itself as a fabric, like this one. When objects of mass are placed on this fabric, they bend or curve it. Here, we'll represent the mass as a blue ball that we can call the Earth. The more the mass, the more the curve. If I put a heavier, more massive ball on the fabric, it will bend it even more. We can call this ball the Sun. So the Sun has a larger gravitational pull than the Earth. Everything in fact bends this fabric. You, your clothes, your dog, even the chair that you're sitting on. Right now I'm being gravitationally attached to this chair. The attraction is so tiny that it doesn't even affect me.
Hey, that's pretty good.
So it actually happens when Isaac drops the pencil, or I drop this slinky, is that nothing is grabbing it and pulling it down. It's only following the curve made by the Earth in the fabric, that is space, until it hits the ground. So back to gravitational waves. Now that we understand gravity as a whole, we can get on to explaining gravitational waves. Einstein created his theory on gravitational waves in 1915, and almost 100 years later they were discovered. They were discovered at LIGO University in Louisiana. But what are they? Gravitational waves are ripples in the fabric of space. They are caused when objects with mass and energy are placed in this fabric. When they move around, they create these ripples. These ripples are extremely small and difficult to detect. The ones that were detected at LIGO were caused by two supermassive black holes colliding almost 1.3 billion years ago. They've been travelling along the fabric of space until they reached us.
To demonstrate this, we will use a ball that we can call the Earth and this bucket of water that we can call the fabric of space. If we put the Earth into the fabric of space and move it around in the fashion that it orbits the Sun, we will see it creates ripples. These ripples will compress or stretch the fabric of space. This will make the distance in between two fixed points either shorter or longer. The distance change is so minute, it is like trying to find a 1 centimeter difference in a stick that is 12 trillion meters long.
This discovery is a breakthrough in science as it lets us observe the universe in a completely new fashion.
And that's gravity!